this lab, you will determine the reduction potential of a redox couple. The redox couple consists of Vo2 plus, in which the oxidation state of vanadium is +5. You notice that the substance actually has a bright yellow color. This Vo2 plus is actually mixed in with sulfuric acid, so this Vo2 plus is in the acidic medium. The second redox couple is Vo plus 2. This is called a vanadium ion, or it's just called vanadium 4 oxide, for which the vanadium has an oxidation state of +4. If you notice that the Vo2 plus complex with vanadium in the +5 oxidation state has a yellow color, while the vanadium as Vo plus 2, the vanadium ion, has an oxidation state for the vanadium of +4, and that has a blue color. So to go from +5 to +4 not only means you go from a yellow to a blue color, but it also represents reduction, where this vanadium has gained an electron to go from +5 to +4. So in this series of experiments that you'll perform, you'll estimate the electrode potential of this couple based upon measuring the redox potential on a bunch of different oxidizing agents and reducing agents. So how will you determine if you have a successful reduction of Vo2 plus, the vanadium in the +5 state, to Vo plus 2, the vanadium in the +4 state? Well, you'll have a successful reduction if you go from a yellow color to a blue color. So in order to test that, remember, for every reduction requires an oxidation, you're going to test a series of what we'll call reducing agents. Reducing agents get oxidized, and in turn, while they get oxidized, they will help in the reduction of V plus 5 to V plus 4. Now this reagent is something that you will make in the lab. This is not given to you. This is given to you. This you'll have to make and then test its oxidation. So if we're going to test the reduction in going from +5 to +4, we're testing really to see whether another couple can convert this yellow color to blue color. After you make this, you're going to test what are known as a series of oxidizing agents, because the oxidizing agents, the substance that gets reduced, will be coupled to the oxidation of V plus 4 to V plus 5. In that case, in the second phase of this experiment, you're going to test the ability of vanadium ion to get oxidized from the +4 state to the +5 state. You'll be testing a series of oxidizing agents themselves that will get reduced in order to determine which one of those reagents will oxidize V from the +4 state to V in the +5 state. So in that phase of experiments, you're going to look for a color change of blue to yellow. So this place, going from yellow to blue, represents the reduction, and you're going to be using a series of reducing agents to test that. Here, going from +4 to +5 is oxidation, and you'll be testing a series of oxidizing agents themselves that get reduced, that catalyze the transition from blue to yellow. The first step of this procedure is to determine the reduction of Vo2 plus. Now remember, here Vo2 plus has vanadium in the +5 state, so the goal here is to attempt to reduce this from the +5 state to the +4 state. Now how do you know if you're successful in getting reduction of this compound? You'll know you'll be successful when this substance turns into a blue or aqua blue color. Now you're going to test this reduction by a series of reducing agents. A reducing agent is a substance that gets oxidized, which in turn couples to the reduction of this. Now it may reduce V plus 5 to V plus 4, or it may not, but you're going to test these substances. And again, these substances are called reducing agents because they themselves get oxidized in order to reduce this. So what are these substances that you will use, these reducing agents, that you will use to attempt to reduce this? Sodium sulfite, this actually will reduce V plus 5 to V plus 4. You're going to need the assistance of a water bath and heat to do that, but this will definitely reduce it. You should see a blue color here. The second one is sodium nitrite. That will be the reducing agent. So nitrite, NO2 minus, will get oxidized to another substance. The third one is sodium bromide. The fourth one is oxalic acid. And in no particular order, the final one is going to be water. So what you'll do is, according to the procedure, take about 20 drops of each of these substances. For the sodium sulfite, you'll just add a pea-sized amount into your test tube. And you're going to look for the color change of yellow to blue. That would represent a spontaneous reaction. It would also represent a successful oxidation reduction couple. Now, however, even though the reaction may be spontaneous, it may need help. Spontaneity does not mean it just happens. So in some cases, if you do not see the transition from a yellow color to a blue color in your substance, you may want to add the addition of heat. Heat may spur the reduction and may catalyze the formation of the reaction that you're looking for as the color change. So look to see which one of these substances becomes successful in reducing vanadium from the +5 state to the +4 state. That will give you one limit. Now that you have determined which redox couple was successful in reducing Vo2 plus to Vo plus 2, the next step of experiments would be to do the exact opposite, sort of flipping the tables. In this particular case, you're going to test a series of substances that will oxidize Vo plus 2 to Vo2 plus. So how do you know if you will have a successful oxidation of vanadium in the +4 state to vanadium in the +5 state? You will know that by looking for a successful color change from blue to yellow. So before you actually attempt to test a series of what we will call oxidizing agents, because these oxidizing agents will get reduced in order to oxidize V plus 4 to V plus 5, before we actually test those reagents, we actually have to make our Vo plus 2. This is the vanadial ion, or vanadium plus 4 oxide. Remember, vanadium is a transition metal. The way we make this is by adding a little bit of our Vo2 plus and some sodium sulfite. So that is a spontaneous redox reaction, and when you do that, you will get a blue color here. And this represents our Vo plus 2, or vanadium, in the +4 oxidation state. Now, in order to do this, you're going to need to add about 10 times the amount of sodium sulfite according to the stoichiometry of this redox reaction. So that is going to be a pre-lab problem that you will do and perform. And once you determine the stoichiometry and according to the balanced redox equation how much sodium sulfite you need to add, you're going to add 10 times more of that amount into your, I believe it's 15 mils of Vo2 plus. You're going to do that, and this reaction with heat is going to produce some noxious SO2. So you always want to have goggles on, and you want to keep this away from your face because the SO2 can burn your eyes and does smell very bad. You can use an inverted conical funnel. Another thing that I'd like to do is to take an inverted funnel, wrap the top with paraffin, and then just put it on here so to minimize the SO2 escape. All right, now that we have prepared our Vo plus 2, that nice aqua blue color is there, we're going to attempt to oxidize this. And the oxidation of the V in the +4 state to the V into the +5 state is going to result in a color change, as you know, from blue to yellowish. So what are these agents that we will use? So these are going to be called, now let's see here, if we're going to attempt to oxidize this, then these agents that we're going to test it are going to be reduced in order to cause this to become oxidized. So we're going to call these oxidizing agents because they will get reduced in the process. So what are these substances? The substances that you will test to see if you're successful in oxidizing V plus 4 to V plus 5 are, in no particular order, sodium sulfate, sodium nitrate, hydrogen peroxide. So once you determine which of these reagents are successful, in this case successful in the oxidation of this, In the first part of the reaction, you determined reagents that were successful in the reduction of Vo2 plus. Now you have limits. You have limits for the vanadium plus 5, vanadium plus 4 couple. You'll determine those limits based on these sets of reactions, and then you'll have a boundary that's to the left and a boundary that's towards the right, and that is the limit, the left-hand limit and the right-hand limit, where you think the redox couple, that standard reduction potential for plus 5 and plus 4 vanadium resides. So that's the purpose of this lab. So make sure you read the lab protocol very precisely. Make sure you know what you're doing, what is being reduced, what is being oxidized, what serves as your reducing agent, what serves as your oxidizing agents, as you test a whole bunch of these redox reactions to see if they're successful in the color change. In the first phase, you want a color change from yellow to blue. And in this second phase, you're looking for a color change from blue to yellow. Which one represents oxidation? Which one represents reduction? All of those things are going to be of paramount importance for you to understand. So make sure you do read this carefully. Make sure you do know how to calculate the reduction potentials from the redox couples. Minimize waste as always, practice safety, and have a safe and wonderful lab.